Okay, so like I was saying, today's assignment could be a little long. Want to make sure you guys don't have any homework, so let's jump right into it. We'll do a couple practice problems, and then I'll get you guys started on your assignment, okay? So today we're going to be talking about something called precipitation reactions. Talk about what that is in just a second, but just make sure you guys title that for your lecture notes. What we're going to do first is basically just fill out the parentheses for the state of matter for the compounds below. So if you guys remember from last time, the two things we can write in the parentheses are AQ, which basically means that compound is soluble in water. Okay. AQ means is short for aqueous. It means it dissolves in water. We can also put S, which basically means that it is insoluble. S stands for solid. So if something stays a solid inside of a liquid, obviously it's not going to dissolve. It's insoluble. Okay. So those are the two things we can put inside of the parentheses. All right, so what we want to do is we want to identify the cation and the anion, so the positive and negative ion. So we'll do this one kind of slowly in the beginning, and then we'll kind of speed through them. So this first one right here is Na plus. This second one right here is F minus. So all we need to do is identify the cation, the positive one, anion, the negative one, and then just line them up on the table. So we got Na and F. So we'll go to the solubility table. We'll find Na right here. We line it up with F. It looks like it's soluble. So what should we put in the parentheses right here? Yeah, AQ. Super easy. And that's it. So basically, you're just identifying the positive, the negative, and then writing down if it's aqueous or not. Okay. Okay, so I'm going to go through the rest of them a little bit more quickly now. We got AgCl, so obviously it's going to be Ag and Cl. So we go to the table, Ag, line it up with Cl, and it looks like this one is insoluble. So we'll write that it is a solid. Okay. Next one right here is NaCl. So we're going to line them up, Na and Cl. This one is soluble, so we write AQ. And then the last one, AgF, we're going to go to the table. Ag and F looks like this one is soluble, so we'll write AQ. So that's it. Any questions on the parentheses? Hopefully not too bad. All right, the next thing we need to do is identify any precipitate, so anything that does not dissolve in water. So which out of these four compounds is the precipitate? Yeah, AgCl. So the precipitate is AgCl. And that's it. Okay, so just make sure you guys have a good understanding of that. Because today what we'll be doing is we'll be basically making it a little bit harder. Okay, because instead of me giving you the full equation, this time you're going to have to figure out the back side of the equation. What chemicals are made based on the starting chemicals. Okay. All right. I'll leave this up here for like 10 more seconds, and then we'll move on. Again, make sure you guys wrote the title of your lecture. Oops. All right, let's move on. Okay, so like I said, you're going to have problems like this now, so I'm going to zoom in a little bit. Now, if you guys notice, in this problem right here, it basically looks the same, the first half, right? You got two chemicals. They are reacting, but now you guys have to figure out the chemicals that are going to be made. Now, it might sound very challenging, but it's actually not too bad. So what we're going to do first, I'll do this first one with you, and I'll have you guys try one on your own. The first thing we want to do in this situation is we want to figure out the cation, so the positive ion, and the negative ion that makes up both of these, okay? So let's start with this one right here. Okay, so what is the cation in this compound right here? Yeah, it's going to be Ca. And what's the charge going to be on Ca? Yeah, +2. Okay, so there are multiple ways you can figure out that it's Ca +2. You can either look on the periodic table. Ca is in the +2 column. You could also look on your solubility table. Ca is +2. So you got Ca +2. All right. Okay, so that means that S is going to be the anion. And so what is the anion or the charge on S? -2, yeah. So again, you can look on the periodic table. You can look on your solubility table. You can also figure out, hey, there's one of each. So they balance each other out. One of them is +2. The other one has to be -2. Okay. So far, so good? All right. Let's move on to the next one. Actually, I'll give you guys about a minute to find the cation and the anion for these two. Okay, so I'll give you guys a minute to figure out the cation for CuCl2 and the anion as well. Okay, take a minute to do that. Problem? Okay, so super simple. You guys should have identified that you got Cu2 plus. Okay, and the anion is Cl minus. Okay, everybody good on that? Cu is one of those weird ones in the middle, right? And so we don't have an MCI. But if you notice Cl, there's 2 of them. Each of them is -1. So if there's 2 of them, to balance it out, Cu has to be 2 plus. You can also look on the solubility table and 2 plus. So multiple ways to find it. But yeah, the best way is to just calculate it using the 2 Cls. All right. Now we got to figure out what chemicals they're going to make. Now, I want you guys to write down the other name for precipitation reactions. So one word for these types of reactions are precipitation. The other one is called double replacement. Okay? Double replacement. Now, the reason why I want you guys to jot this down is because it kind of tells you how to find the answers. You're going to do 2 replacements. Okay? They're going to replace doubly. Now, what that means is, so you guys start off with these ions. Now what's going to happen is the positive of one of them is going to react with the negative of the other. And then the same as well. The negative of one of them is going to react with the positive of the other. So that's how they are going to react. They're basically going to replace each other 2 times. There's 2 different replacements going on. Okay. So Ca2 plus is going to react with Cl minus. So we're just going to do the same thing we've been doing. We're going to write Ca and Cl next to each other. Now, if these 2 react with each other, do we have more positive energy or more negative energy? Yeah, so we need more negative energy, right? So we're going to add another Cl to balance it out. So it's literally the same thing we've been doing. We're just putting it all into equation form. Okay, so that's the first compound that's made. The next compound that's made is obviously going to be Cu and S. Now, these guys are +2 and -2, so they balance each other out. And so we're good to go. All right, and we're almost done. Okay. Now, whenever you finish writing the equation, there is one thing that you do need to make sure to do, and you always need to make sure to balance the equation. Okay, so you guys might remember this from way back when we first learned stoichiometry and balancing. Balancing just means you got to have the same number of each element on both sides. So you just need to do a little quick inventory check, okay? So there's 1 Ca here. There's 1 Ca here, so we're good to go. There's 1 S here. There's 1 S here, so we're good to go there. There's 1 Cu here. There's 1 Cu here, so we're good to go. And 2 Cls, 2 Cls. So we're balanced out. So this one's nice because it's balanced right as soon as we finish. But you will see some problems where you will have to add numbers like in the front in order to balance it out. Okay, but we'll go through that in the next example. All right, and then last but not least, we need to fill in the parentheses for these. So I will give you guys about 3 minutes to do that as well. Figure out which ones dissolve in water and then identify the precipitates. And that's it. That's pretty much what the precipitation reactions are going to look like. And this will be helpful because next week, we are going to be doing the lab for this part. And so you'll be basically reacting these clear chemicals and seeing if they make a solid or not. Okay, so what we have to do now is figure out what the precipitates are. So same thing as before, just line them up on the solubility table. We got Ca and S. Ca is right here. We line it up with S. This one is soluble, so we're going to write AQ for this one. Okay, so this guy is AQ. Okay, CuCl2 is Cu and Cl. So we go to the solubility table. It's going to be Cu and Cl, which is soluble. So we write AQ right here. Okay, the next one is CaCl2. So we look for Ca and Cl. So Ca and Cl, which is soluble. So we're gonna write AQ for this guy right here. And then the last one is CUS. So we line up CU, oops, not gonna buy it, CU and S. And this one is insoluble. So that means this one is going to be our solid. Okay, so which one is the precipitate? Yeah, CUS is going to be our precipitate. Okay, and that's pretty much it. That is basically all you got to know how to do. The trickiest part is figuring out the equation. The key thing I do want to let you guys know or remind you of is that you do need to balance the equation. And the next problem we do, you have to make sure it's going to be balanced. Okay, it won't balance itself like it did right here. Okay. All right, but with that being said, you guys think you can try one on your own, beginning to end? All right, well, ready or not, let's try it out. Okay, so this is what your assignment problems are going to look like. I'm going to give you guys the first half of the reaction. I guess I was nice here, and I told you guys that it dissolved in water already. But you're going to have to finish the equation, make sure it's balanced, and then same thing as last time, make the picture and identify the precipitate. So I'll give you guys about 5 minutes to try it out with the person next to you. We'll go over the answer just to make sure we're all on the same page. We're ready to go, and then we'll get started on the assignment, okay? Take about 5 minutes to do that. Okay, so I wrote down the ions for you guys just in case you needed them. But you should have noticed NH4 plus and SO4 2 minus here, Li plus and Cl minus. Now, to find the products, you just need to make sure you do that double replacement thing. So positive of one of them, negative of the other. So the first compound that you're going to make is NH4Cl. We don't need to add anything because the positive one and the negative one balances each other out. And then for the next one, you're going to get Li, and that's going to react with SO4 2 minus. Okay, but you guys should notice here that you need more Li to balance out the sulfate. So we're going to put a 2 right here. Okay, so those are the two products. We're not done yet, but yeah, what's up? There's a 2 like outside the parentheses. Yes, great point. So yeah, that's what we have to do for the balancing part. So like Layla said, there's a 2 right here. So if you guys notice, we have 2 NH4s, right? But on this side, how many do we have right now? Only 1. So we need to double it. And so what we're going to do is we're going to put a 2 in front of this entire equation, which means that now we have 2 NH4s. Okay, now, but that changes something else, right? How many Cl's do we have now? We have 1 here, but we have 2 because the 2 in the front. And there's only 1 right here. So we got to make sure we put a 2 in front of LiCl, which works out in our favor because right here there's 2 Li's and we got to make sure that's balanced out as well. Okay, so this is your final answer. This is exactly the way it should look. If you have anything different, if your numbers are in a different position, if you switch anything up, then it is incorrect. Any questions on this setup? You guys chilling? Okay, so the trickiest part is the balancing. Just make sure you guys double check your counting and you should be good. Yeah, what's up, Aaron? What about like SO4 or like would that be right or would it be wrong? If you wrote SO4 Li2, that's technically correct, but I always recommend putting the positive one first because for the naming, it might mess you up. Yeah, good question though. Yeah. This one right here? Yeah, because SO4 is -2, Li is +1, so you need 2 of them to balance out the SO4. Yeah. You see that? All right. Last but not least, we have to do the state of matter. Now, I did the left side for you because I love you guys that much. But you guys should see that both of these are also aqueous. Okay. So kept it simple. All right. And then lastly, for the picture, we got our 2 solutions. So make sure you guys have these boxes on your answer. You're going to see that the first on the left side of the equation, remember this splits the left and the right. You have NH4 plus floating around in your solution. You also have SO4 2 minus, and they split up because they dissolve in water. Okay, you also have LiCl, so that's Li plus and Cl minus. Okay, so they're just floating around. Okay, now if you look on this side, do we have any solids that form? No, it's still both aqueous, so they're just floating around still. So you can do the same thing, just split them up. And then they're just floating around in your solution. And that's it. So in this situation, we don't have any solids forming. So for precipitates, there are no precipitates. Okay, if you want to shorten that, you can just write NP. That's no problem. Been working on that one for years. All right, any questions? Okay, I'll leave this up here for you guys so you guys have a reference to work off of. You guys can get started on your assignment. Let me know if you have any questions.